Okay, so here's a lesson on how to solve conservation of energy problems if we have non-conservative forces. The non-conservative forces that we're going to have in this case are going to be friction and air resistance. So let's take an example of this. If I slide a frying pan along a table and I give it a good push, it's going to slide and end up over here. So while it was sliding all along this, it was moving. So it had kinetic energy. So there were some joules of energy that we have. But here at the end, if we go through our questions, is it moving? No. So there's no kinetic energy. Is it somewhere other than height equals 0? No. Is there a spring? No. So there's no elastic. So we have 0 joules of energy. So that kind of goes against the conservation of energy, because if you have joules, it's supposed to be the same later on. But here we can clearly see that we have a different value. So how do we approach solving these problems? Well, we know that we have ME1 equals ME2. The joules of ME1 are equal to the joules that we have at some point later. But what we're going to add in here is plus work non-conservative. And in this case, this is the work done by a non-conservative force. And what this is going to do is it's going to tell us, so what this piece does is tells us how many joules was lost to a non-conservative force like friction or air resistance. So for example, maybe we start with 100 joules and maybe there's 20 joules of work done by friction. So we lose those 20 joules, and that means we would have 80 joules later on. That could be, a kinetic energy of 80 joules or a gravitational potential energy of 80 joules. So when looking at this equation again, we have ME1 plus work non-conservative equals ME2. And I have a picture of an ATM here, because think about this. This is kind of like the money that you have plus your transaction fee equals the money you have later on. So let's say that you have $80 in your bank and you have a transaction fee of negative $3 when you take that out. Well, now you might have only $77 because of that transaction fee. Work non-conservative is the same idea. Let's say that we have a 2-kilogram textbook and it is 7 meters above the ground and we drop it. Let's calculate how fast it's going when it reaches the ground. Well, we do our ME1 equals ME2. It starts up in the air with gravitational potential energy H. It's not moving, there's no elastic. When it gets to the bottom, it has kinetic energy 1/2 mv squared. Again, it's not any height or elastic at the bottom. So when we go through to solve this, mass can cancel out. And what we get is gravity 10, height 7 equals 1/2 v squared, or 140 equals v squared. And that results in a V 11.8 meters per second. But let's say when you actually drop this book and the book falls to the ground, what if you find that the velocity when it reaches the ground is only 8 meters per second? Well, that would mean that there's less joules at the end than there were in the beginning. So we could find out how much energy is lost. And the way that we would do that is we would do mechanical energy 1 plus work non-conservative equals mechanical energy 2. So that energy lost is your work non-conservative piece. So we started with MGH plus work non-conservative equals, at the end, 1/2 mv squared. Remember that the mass of the book was 2 kilograms, G is 10, and the height was 7 meters, plus work non-conservative is 1/2, 2 kilograms, and now our velocity at the end is 8 meters per second squared. So here we have 2 times 7 is 14 times 10, 140 plus work non-conservative equals 8 squared is 64, and those cancel out, so 64. So we can subtract this 140, 140, and we find out that the work non-conservative is negative 76 joules. So what that means is that there was 76 joules of work against the book as it fell. So what can we do with that? Well, we can actually find out what the force of the air resistance was, because we know that work equals force times displacement, and we know that this was negative 76 joules, actually cosine theta, and when the book falls and air resistance is up, that means theta is 180 degrees, and cosine 180 is -1. So we could find out what the air resistance force, we don't know. We know the displacement, it fell 7 meters, and we have -1 for our cosine theta. So then the friction force, or the air resistance force, is 10.86 newtons. So scrolling back to see all this again, we started and we found out what was the V if we have no air resistance. And since we had our joules of energy to begin with was equal to the joules of energy at the end, it was 11.8. But when we dropped the book, we found out that it was only 8 meters per second at the end, which means we lost energy. So we took our energy at the beginning, we know our energy at the end, so we could find out how much joules was lost during that. And then we could take that idea of those joules came from the work done by air resistance, which was FD cosine the angle, and we could find out that the force of air resistance in this case was 10.86 newtons. So in summary, if we have friction or air resistance, those are non-conservative forces. So there's work done, which is going to take joules of energy away. So the equation, instead of ME1 equals ME2, becomes ME1 plus work non-conservative equals ME2. And this is like our transaction fee. It's taking energy out of what we have so that the joules at the end are going to be less than the joules at the beginning.